Hi, today we'll be working on some pointers again in C, so we'll be continuing with the pointers tutorial. So this is just an example. I've commented it out because we don't really need to test this code. It's just an example. So this question is commonly asked, for example, on interviews. So it's the swap question. So we can swap something, as you probably know, or if you've seen before in other books. Like you can have a swap call to swap two values, right? Like that. Let's just say that's in main, and then below we have a function called like void swap, which takes two values, int x and int y. Whoops. So here, if we had like int temp, because if we just use two, it doesn't work. You need a third variable to swap them, as you've probably seen this before. Or else you're just going to swap two values back and forth twice. So here we can just say we can say temp points to x, the parameter x. Then here we can say x points to y. Then here we can say y points to temp. So we'll look at swap without pointers and then with pointers to show the difference. So what's happening here? So we have int temp. So we have our function here with two parameters that gets passed in. When we say int temp here, so we're declaring a temp variable, then we're saying temp points to the parameter x. Then below it we're saying if temp points to x, then we'll say okay, well x itself points to y. And then finally we'll swap the last value by saying, well, y points to temp because temp was pointing to x originally. This is kind of like a placeholder. Temp points to x, and then we're saying, okay, well, x transfer to y, that's like the easiest one. Just switch it. But if we said x points to y, right, and now we say y points to x, y is just going to be what it already was. So here we say y points to temp, so we have a placeholder, temp, a temp variable, temp points to x. Then we say, okay, well, x points to y. Then finally y points to temp. So this is a process to swap two variables. Excuse me, it's a process to swap two values. You need to have that third variable. So if we do it with pointers, this is from a book, so this is how they did it. So let's just say we have something similar. So in the call to swap, then instead what they do is they say, okay, we'll swap, and then we want to pass in a memory or an address of A, comma, and then an address of B. So it's taking a pointer address, but in the method itself, it just takes a pointer value. So I guess that can happen. So either way, it's just good practice. So here we have int and then pointer, which is px, so it's a pointer x. Then here we have int and then pointer. Oh, they do it this way too, just to show that you can also call pointers like this, py. So it doesn't really matter whether you call a pointer with int space asterisk px, or you can just have int asterisk space py. It doesn't matter. Both ways are fine. I find this way better, the first way, Because sometimes if you're looking at py from a distance, then it can be like, oh, well, is it a pointer? Then you have to look back. So this way is easier for me to read. Whoops. So it doesn't matter, you can be asked both ways. Just know that you can be asked both ways are correct. So here we have the same thing, a temp variable int temp. So what we're going to say here is we're going to say, okay, well, temp points to the pointer value px. Then here we're going to say, okay, pointer value px points to the pointer value py. Then lastly, we just have pointer value py points to temp. Because temp itself was just storing the pointer value. I mean, I'm sure we could have just gone pointer temp too. It's just showing the different ways you can use them. Sometimes they can be like mixed and matched. Because temp wasn't storing an address, usually the variable stores the address, right? Like the ampersand address. But in this case, we're just saying, okay, well, in other cases you may have it pointing to a pointer value itself, like another variable. So here we're just calling a variable to point to a pointer value. So if px is holding 5, then temp would just hold 5 and not a memory location. So again, what's happening is we have our temp variable, which is just declared as an int, and then we're saying, okay, well, temp points to the pointer value px. And we're saying, okay, well, the pointer value px points to the pointer value py. That's just like x points to y, but pointer values. So we're directly changing the pointer values. And we're saying, okay, well, the pointer value py is just going to point to temp to get that pointer value px to change. So that's the example. So if we could have some values here to test. So if we have like let's see if we have a variable name a. So I'll have to write these out. Actually, we won't really be able to see how to debug these, so that's okay. We could just skip this. You guys get the idea. We'll just move on to the next example. So we'll just go to pointers and arrays this time. We'll just be doing this in main again to just kind of like the last video. So this is from a book, and they haven't really put these in functions. They've just written these out like notes. So I'll just kind of go with the flow here to just show you guys the example. So we'll just say we'll just include the header file, standard header file. So hashtag include stdio.h. Then here we'll just have void main, pass in void for parameters. So we'll have a float pointer here. So we'll say float pointer px. Then we'll have a float x array of 10 elements. So here we're showing the example of pointers and arrays, because arrays, there's a strong relation between pointers and arrays. The way pointers are laid out is they are laid out basically like an array. Because remember, memories are the memory cells themselves are laid out with byte arrays. So basically they use arrays themselves, so a pointer is really an array in the back end. So here we'll say, we'll just have some notes here. We'll say px is ready to store an address. It's a pointer. Then here we'll say x represents 10 float type variables. They have some more stuff here, so we'll just say, actually I think these are notes from my professor, like old notes, so we'll just go with the flow. I'm kind of like manipulating them, changing them around, so hopefully you guys understand the idea. So we just have, this is, oh, that's confusing. So we just have the memory locations, or so we have the indexes of the float array of 10 elements, which goes 0 to 9. Right? Array of 10 elements is index 0 to 9. So we have, at the end we have x to the power, or sorry, x to x of array index 9. So that here we say that, so we have these indexes that are allocated in consecutive memory area, or just memory. So they have a final note here. X has the address of x to the power, sorry, not to the power, what am I thinking? So x to x of array index 0. So I wouldn't worry about that, they're just maybe just telling you how the pointer arrays work in the back end. So just, if you're confused about that, that's okay, don't worry. Then here we'll just have float y. At least know this part up to that ending. They're just saying basically x starts at the address of x of array index 0 as well. That's what it could mean, so just go with that. So we have float y. That's just declared to nothing right now. So here they do a bunch of declarations. They do it on one line. I probably won't be doing it on one line, so we'll say x of array index 0 points to the value of 2. We'll just space these out. So we have x of array index 1 points to the value of 3. X of array index 2 points to the value of 4. X of array index 3 points to the value of 5. X of array index 4 points to the value of 6. These are just going up, I think. 2, 3, 4, 5, 6. Yeah, so then we have x to the power of 5. Sorry, not to the power. X of array index 5 points to the value of 3. No, wait, is that correct? So, no, 7. So we'll just say 7x to x of array index 5 points to the value of 7. Looks like the rest are empty. So the rest of the indexes are just empty at this point. If it's yeah, so they might be 0.0000 if they're not garbage values. So we have x to the power of 0 points to 2, x of array index 1 points to 3. Index 2 points to 4. Index 3 points to 5. Index 4 points to 6. Index 5 points to 7. So those are our declarations or initializations, and then we have px points to x here. So maybe I can move these back up. So then here we'll say px. So just the pointer px, I guess. Or just the value of px itself, not the pointer value, points to x. Then here underneath we'll say, okay, well y, we're going to say y points to the pointer value px, right? Y points to the pointer value px. So we don't have any value for px at this point. Do we? No, okay, yeah, so we do. So we have px pointing to x, right? So px points to x. And they're telling us here, they told us that x itself is the address of x. So in regards to arrays, x has the address of x to the power of, in regards to arrays, x has the address of x of array index 0. So x has the address, I'll just copy that again. So in regards to arrays, we'll just keep this note available somewhere like here. So x has the address of x of array index 0. So I guess they're telling us in regards to arrays. So we're saying, okay, well px points to x. Y points to px. So right now let's just say, okay, well we want to check what the value is. How can we do this? So let's say printf, we want, what do we want? We want the value of x right now just to see what it really is. So we'll say, okay, we want a %d and we want a %p. Then we'll say here we want x and we want x, x. Let's say we want two more. Here we want %d and %p again. Then we want here, we want address of x, and then we want address of x. So I'm just, this is just on the spot here. It's not part of the notes. So hopefully this is something that will show, because what I'm trying to show you guys is what x really is at this point, just to show in relation to pointers and arrays, what is x really at this point. So let's just test it out. Let's set some breakpoints and set Control S, and then I'll hit the debug icon, and let's just see what it is at this point. So they have some other examples below to test what the other values are. So we have x of 0 points to 2, so let's just go through these. Okay, we're saying, okay, well px points to x, so what was px? It's a pointer, and px is just the value. Okay, so here it's showing px is a memory location. That might be because it's a pointer, But okay, we're saying, okay, well, y points to the value of px. So here we said x has the address of x to the power of 0. X has the address of, so x to start, because arrays start at 0, right? Correct? So if we are not in the middle, then I guess we're at the start. We're at the left or the start of it. I guess it could, not left, because I guess it can be written down to up, up to down, so it could be up, left, or let's just say it's at the start. So x has the address of x of array index 0 so initially. So if we have an array with elements, then the value of x will have the address of x of array index 0. So we're saying px points to x. That could be because it's a pointer. Y points to px, so sorry, y points to the value of px. Px points to x, pointer value. So px is pointing to the address of x. Y points to px, so the array is starting at x of array index 0. That means y currently points to 2. So let's see what this printf gives us. So you guys can see that on your output that we have okay, so we got some discrepancies here. So we have a negative, it seems like it's a garbage value. Because what do? We print it out. Oh, sorry, you know what? My mistake here. We need %f, because this is a float, so %f, %p, %f, %p, so we'll just debug that. Go to that line. I'll just set the breakpoint. Oh, wait, I already have one up there. So I'll stop that, take that one out. I move the breakpoint to line 16. I'll hit the debug icon again. I should have saved it. Okay, that's alright. So we'll step over that line. Check your output. You can't see mine because it's an external window. Okay, so now we have some values. So we have, what are we printing out? We're printing out what x is. So it looks like again we have some discrepancies. So we have 0.000 with trailing zeros. So it's telling us in regards to not pointers, right? Then the value of x itself without pointers and without arrays, it's just telling us, well, it's just telling us what the value of x is in the array. Then in regards to not pointers, and this line here is not relevant basically, so it's just telling us that the value of x is 0. The float value of x itself is just 0.0000. We were expecting 2. We might have been expecting 2, but now we're being told that this line basically is just true to when we're referencing the pointers, the pointer itself. So if we're setting a pointer to point to x, then it's going to say that, okay, well, if we're setting a pointer to point to x, then it's going to start at the start of the array. It's going to be pointing to that value at the start of the array, so index 0. So x is going to have has the address of 0 because we're starting at index 0 of the array. That's only in regards to pointers. If we just print the value of the float straight up of just x with no pointer format specifier, then we're just going to get 0. So the pointer, for %p, the pointer format modifier or format specifier, we got, yeah, so format modifier, we got a a memory location, so that should be correct. And then for the float value of the address of x, it's just telling us that it's 0.000. And if we want the pointer value of the address of x, we're going to get the same memory location. So hopefully that clears up some questions. So this is just true in regards to pointers. So we'll just say true in regards to pointers only. So we'll just move on to the next part. So if we have another printf statement here, what's that? Whoops. So if we have printf, then we'll say, okay, we want a %f here, %f, and another %f, new line, then we want x of array index 0, then pointer value px, and then y. I feel like for a pointer value, they should use %p, but this is how they did it. So we have we have %f, 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 new line, x of array index 0, pointer px, and y. Alright, so let's execute that line. We'll just put a breakpoint there since we already went through that. I'll save it. I'll start debugging and I'll just I'll step over this line. So I hit the step over button and the debug buttons or the controls. Okay, so we're saying, okay, well, if we print the float value of x of array index 0, we're going to get 2, of course, because that should just be normal. And okay, so then if we want so you can call the pointer value as a float, I guess. With %p, it should be the same thing. So we want %f, and then that matches, or that corresponds to pointer value px. So for that one, for the pointer value px, we want the float of that, which is pointer value px. So what's that pointing to? So we're saying px points to x, which is the pointer px points to x. Maybe I'll just say that from now on. So the pointer px points to x. X is the array. In regards to arrays, it'll start at the beginning of index 0. So I'm just saying, okay, well, y points to the pointer value px, which should just be the pointer value px should be the start of the array, which is again 2. Then y also, we're saying it points to the pointer value px. As you can see there, it should also be 2. So hopefully you guys can see that on your output. And let's just say, okay, well, we want to be super crystal clear here, so we'll say we want a %p and we want comma pointer px here just to make sure. So we'll save that. I'll just step over that after I debugged it. So we'll just say so for a pointer value, so %p of px, we're getting 4. Actually, we're getting a garbage value. as pretty much a garbage value. So if we want the format specifier p at the pointer value px, we're getting a garbage value, so I guess you'll need to print them out with floats. So yeah, we're just getting a garbage value for that. Pointer value px, it's just a garbage value, so just keep that in mind. It's a little confusing, so just note that they printed them out with %fs here, and we'll get into some more examples with the format modifier p again after, just to show the difference. Did we show the difference before? I believe we did. I believe because it's an array that the pointer value itself is just saying, okay, well, we don't really know where the array is starting, since the pointer value px just points to x, and it's just going to print a garbage value. So here we'll just make some modifications. So we'll say, okay, well, px points to the address of x of array index 2. So px points to the address of array, of px. So the pointer px points to the address of x of array index 2. Then here we'll say y points to the pointer value of px plus 2. So when we say plus 2, that just moves up the indexes 2. So here we'll just have another printf statement. I think it's exactly the same one as this, so we'll just we'll take this part out. Then we will copy that, just paste it down here, code reuse, and then we'll just put that down here. Okay, so yeah, so we'll just move the breakpoint here. Hopefully I'm not confusing anyone, so we'll just save that, and then we'll hit the debug icon. Okay, so we're saying px points to the address of x of array index 2. So px points to x of array index 2, the address of x of array index 2. Then we're saying, okay, well, y points, because originally px was pointing to x, now we're actually setting it to a formal address here, and then we're saying, okay, well, y is going to point to the pointer value of px. So what was px? So now px has changed. So address of 2, right? So px points to the address of x of array index 2. Then we're saying, okay, well, y points to the pointer value of px plus 2. So it should be here to x of array index 4 equals to 6. So we'll just y points to 6. So there you go. So it just adds them by 1. So if we're saying add them, so if it just adds, if we're saying a pointer value plus 2, then it just adds them in regards to arrays, pretty much. It just adds them by indexes. So if we add 2 to array index 2, then we get 4. If we add 1 to array index 2, we get 3. If we add 3 to array index 2, 2 plus 1 plus 1 plus 1, we get 5. So it just adds them like that. So if you guys understand that, so then we will execute this line here, printf. Then we're saying, okay, well, we want the float value of x of array index 0. What do we have there? That should be 2, because we just want the float value of x array index 0. Then we're saying, okay, well, we want the value of px. Sorry, we want the pointer value of px as a float. So px last was pointing to the address of x of array index 2. That's pointing to 4. So the value should be 4 there, the pointer value. So that one should be pretty easy. Then we want, okay, well, we want, then lastly we want what y is pointing to as a float. So we're saying, okay, well, y is pointing to the pointer value px, which is currently stored at address of x of array index 2. Then we want that plus 2. So address of px, which is address of px is starting here, because we're saying px points to the address of x of array index 2. Right? So that's going to start at x of array index 2, which is at 4. Which is storing the value 4. Then we're saying, okay, well, we want 2 indexes up from that because it's adding 2, which would give us 6. So it should give us 6 as a value. So hopefully you guys understand that. That's the end of this video of this pointer example. We're doing a few more just to practice perhaps some more array index manipulations. And then we'll look at a couple more examples. Maybe it's some out of memory example, some character pointers, string pointers. So there's a bunch more examples here to do. And then finally we'll have file handling. So we'll look at file handling pointers. That's going to have some examples too. So in regards to pointers, it could be maybe 6-7 videos more. I'm thinking less than 10. Hopefully. Actually, yeah, there's quite a few more examples here. So then after all those, we'll get into structs, which should be fun, because that's more like object-oriented stuff. Do we have structs with pointers? Yeah, so then we'll have a structs with pointers example. We'll look at type def and union. And yeah, so yeah, there's a bunch more examples. So hopefully if you guys want to see those, you can subscribe to the channel. You can give the video a thumbs up, and I'll see you guys next time. Take care.